Hello everyone. So in today's lecture we are going to study one of the linear data structure. Till now we have studied stack, queue, variants of queue, that is circular queue, double-ended queue, right? So today we are going to start with another linear data structure, that is linked list. So we can see that first of all, what is linked list? So till now, whatever data structure that we have studied, linear data structure, stack, queue, all those, the one thing is common, that we use the contiguous memory location, right? Now here in the linked list is a linear collection of data elements whose order is not given by their physical placement in memory. That means it can be scattered anywhere, right? It should not be it's not compulsory to have the contiguous memory location, right? So the linked list consists of like series of structures. That structure is known as node, right? We can say that linked list is a collection of nodes, right? And that can be randomly scattered anywhere in the memory. It should not be the contiguous, right? It's not compulsory to have the contiguous memory. Now what is node? So node is a one kind of structure that has two fields here, as you can see, one that is a data field and the another one that is an address field. So data field stored the data, whatever information that you are going to store, that's a data field. And the address field, now what is the working of that address field? Address field will store the address of the next node, right? So as you can see that here we have this collections of nodes, right? So linked list, that is a collections of node, more than one nodes. Here you can see we are having three nodes, right? So three nodes are there. So here like first x1, that's a data part, right? That is stored by the node 1. x2, that's a data part that is stored by the node 2, and x3, that's a data part stored by the node 3. Now this link part, right? So link part, what it will store? It will store the address of this next node, right? Similar way, here this link part store the address of the next node, right? And here in the last you can say it's a null, right? Why it is null? So after this x3, this last node, we are not having any other node connected with this. So that means this my linked list is having three nodes, right? Not more than that, right? So if we are having only three nodes, so last node, the link part of the last node should be null. That means that that will tell us that after that I am not having any other node, right? And the most important thing is like first address of this node, like as you can see, for example, I can say that that's the location 1024, this is location like 2137, and this is like 1111, right? So these are the addresses, right? Addresses of this particular node in the physical memory. For example, right now, actually it is in a binary form. Right now I have written randomly, so that is, this one is 1024, this is 2137, right? So here, like in the first node, address of the second node, so that means 1024 will be here, right? Then here address of the next node, that's a 2137, so 2137 is there, and then null, right? So in a memory, like I can search for this data, right? If that data is not there, right? Suppose I'm searching for a particular data, like for example, let us say like 27, right? Here I'm having like x1, that's a 5, x2, that's a 7, and x3, that's a 9, and I am searching for the 27. So first it will compare with the 5, so 5 and 27, that's not equal, right? Then it will go to the next node via this link, right? Using this link, it will using this address, it will go to the next node, right? Now what about the address of the first node? How can we start with the address, right? So we will be having one pointer variable, that's a head, right? And what's the working of head? So head will store the address of the first node. So that means this 4 times 1, 1, 1, 1, 1 will be stored in head, right? So this is a very simple linear data structure, right? It is like it is combined in such a way that it is in a sequential manner, but in a memory actually it is not in a sequence. The memory can be scattered, right? Now why we use this, why linked list is most popular? So for that we need to learn the limitations of array. right? Till now we have implemented stack and queue, right? Both we implemented using array, right? So what are the limitations of array, right? So the size of the array must be known in advance, right? So like if I am creating a program, so at that time only I initialize the size of the program. Size of the size of an array, right? So suppose like let us say 10, right? So my array can be of 10 size only, right? And like execution time, at the execution time, if I want more than 10, right, then I cannot have it, right? I need to change it. I need to go to the program and I need to make changes in that particular program, right? Then and only then I can access more than 10 datas, right? If like 10 data is allocated, like 10 memory locations are already allocated, and if I am making use of 3 of them only, then also the rest of the 7, that is waste, right? Because it's already allocated dedicated memory for that particular array. No other variable or no other array can make access of that, right? So that is one of the limitation of array. Then another, like increasing the, that's the same thing what I have told you, that increasing the size of the array. If I want to change the size, I need to go to the program and I need to make the changes, right? So that is like, it is very time consuming process, right? We need to go to the program, right? And like at a runtime it's impossible, right? At a runtime we cannot change it, right? Then another thing is it should be contiguous, right? Array, as you know, that array is a collection of data, but it is in a contiguous in memory, right? So first data is stored at 1024, so next data can be stored at 1026 only, right? Depending on the size of that particular data. If it is a 2 byte, so 1024, 1026, 1028 and so on, right? So it should be in a contiguous, right? So like that creates the like fragmentation in the memory, right? Suppose like we are having a memory of 1 terabyte, right? And like in between like 2 bytes of memory are like not of a use. So if we want to make a use of that, we cannot use with the use of array, right? Because array always needs a contiguous memory location, right? So to overcome that, we have this linked list, and these are the advantages of linked list. That very first advantage, that like it allocates the memory dynamically, right? What it means dynamically, that means at a runtime, right? Not at the compilation time, at a runtime it will allocate the memory depending on the requirement of the program, right? So we usually use malloc or calloc for that. Malloc, that is memory allocation, calloc, that is contiguous memory allocation that we use, right? So at a runtime, at the execution time, it will allocate the memory whatever needed by the program, right? Another thing, like it should not be contiguously present, like if it is a scattered in a, like memory locations are scattered, as I told you earlier, that first one is 1024 and second one is 2134, then also it's fine, we can make a use of it, because ultimately in a linked list we are maintaining the address in a link part, right? So we can directly access from that as well. Another, size limitation, right? There is no size limitation, because as you know that memory allocation is done dynamically. So like at a runtime, whatever, like if you want 10 memory location, it will allocate you. After like after some operation, if you want again the memory, then it will allocate you depending on the whatever operation you are performing, right? And even like if you are deleting some element, right, so that particular memory is going to be freed up, right? So that would be accessed by another, right? So these are the advantages like over array. Now there are 3 variants of a linked list, right? Basically we will be having 3 variants of linked list. First one is singular linked list. So as you can see over here, like singular linked list, that will have only 2 part, right? That node will have only 2 part. First part, that's an info part. Info part, that means a data, right? Whatever data we are storing, right? It can be a character, it can be an integer, it can be a float, anything, whatever data, for what purpose we are using this data structure, right? For storing the information or storing the data, right? So that information should be here, right? Data is here. Then this is the link part, and link part will store address of the next one, right? So in this, like we are having this first node, it would be pointed by head, right? Then here we'll be having the address of the second node, right? Here we'll be having the address of the third node, and this node is not connected to anything else, like so here we have this null, right? So in this like movement, if you want to search for something, if you want to traverse, right, that would be in a forward direction only, right? Forward direction movement is possible, right? And if we see the structure of this node, because this node is not readily available, we need to create it using the structure, right? So if we see the structure of a node in a singly linked list, right, so it's a struct node, right? Here we are storing integer info, right? Why integer info? That depends on what data you are going to store. Here like I have character, right, a b c that is stored, right? So instead of this integer we can have character, right? If I want to store the integer data 4 5 6 like anything, I can write integer info. If you want to store float data, you can write float, right? Then so this is like the first part, that's the info part, right? So this is for this info part, integer info, right? Ultimately it's a kind of a capsule, right? In a capsule you will be having like little bits, right? So it's a kind of a capsule, this entire structure. So that is structure node, right? Inside that first part, that's the info part, so integer info. Now the second part, is a link part, right? So link part will store address of the next node, right? So that's a star link. Why? Because wherever we use address, right, so for that we use pointer variable, right? So as you know that pointer will store the address of the next variable, right? So here we are going to use the pointer variable, that's a link, so we used to write star link, right? And what will be the data type, right? So star link, it is a pointer variable, and again it is pointing to another node only, right? Usually suppose I am having a that is equal to 5, right, and I am creating one pointer, that's a star b, that will store the address of the a, right? So the data type of this pointer will depend on the whatever data is stored in this a. Why? Because it is storing the address of that particular variable, right? And here as you can see, star link will store the address of the entire next node, right? And what the data type of this node? So that's a one kind of structure, so that's why we have struct, node and star link, right? So I hope you understood this structure of a node, right? Then the next variant we have, that's a doubly linked list, right? So as you know, as we have seen, in a singly linked list we can move only in the forward direction, right? So we can have only the address of the successor only, the successor node, right? Here we'll be having a successor as well as the predecessor node. So here as you can see, the node is divided into three parts, right? The middle part is info part, where you are going to store the data, right? Then this part is a next part, it will store the address of the next node, right? And here we'll be having the previous, that means it will store the address of the previous node, right? These are the pointer variables, you can take any name, right? You can like a next pointer, previous pointer. Here I am referring next and previous, right? So here this is my first node, right? So this address, suppose this is like 1024 and this is like 2041. So here the address of the next node, that means here 2041. And here address of the previous node, and as you can see address of the previous node, that means here I am having 1024, so this is like 1024. So as you can see over here, the previous part of the first node, that is null. Why it is null? Because this is my very first node, so before that I am not having any other node, so the previous part of this node, that is null. Similar way, the next part of this null is null, right? Because we are having only two nodes in our linked list, right? And the first, this is my first node and this one is my second node. So first node is always pointed by head. That is again a pointer variable. Similar way to pointing the last node, will be having another pointer variable that is called as tail. Right. So in this, like in doubly linked list, we'll be having two pointer variables, right? First one, that is a head, and another one is a tail. Head will point to the very first node of your linked list, and tail will point to the last node of your linked list. The next part of your last node, that always should be null, and the previous part of your first node, that is also like always should be null. Right. So this is about doubly linked list. Now there is a slight difference in the structure, right? So what will be the difference? So again, similar way we are having this struct node, right? Integer info, right? Whatever data you are going to store, whether it is of integer data type, you can write integer. If it is a character data type, you can write character. Float, you can write float, right? It depends on what kind of data you are storing, right? Then previously we'll be having only one pointer variable, that is a link, right? So star link we used to write. Here we'll be having two pointer variable, one that is a next and another that is a previous. Again, next will point to the next address of the next node, right? And previous will store the address of the previous node, right? And so we'll be having the star next and star previous, and the data type of that's a struct node, right? And the last another variant, that is a circular linked list, right? Now this linked list, circular linked list, you can implement this linked list using singly linked list as well as doubly linked list. So this kind of variant in this, like you can implement this using both of this. Here I am having example of singly one only, right? So what is the difference in like circular linked list to the normal linked list? So as you know that till now we have seen like in a singly as well as in a doubly, the next part of your last node, that's a null, that indicates that we cannot go further, right? That is the end of my linked list, right? Here the difference is from that position we can again come back to the first node, right? So we need to make it circular. Instead of this null, like it will point to the first node, right? So here we'll be storing the address of this. So again this is like 1024 and this is like 2144. This is a doubly linked list, right? Implementing not using singly, using doubly, right? So this A here will be having like 2144. This is a previous, so here we'll be having 1024. Now here the next part is also 1024. Why the next part is also 1024? Because it will go in a circular manner. So after this again this node is only there, right? Similar way here, instead of null, 2144 will be there, right? Because that is only the previous node. So it's like a chain, simple. If we are having a open chain, right? So open chain that have two dead ends, right? One that's the starting and another that's the end, right? And if we like combine that two end, right, we make a circular chain, right? So you can move in a circular manner, right? So that's a circular linked list, right? Here again this one thing I need to clear, that if you have a singly linked list you can move only on the forward, right? If you have a doubly linked list you can move forward as well as backward, right? And in a circular there is only one difference, the last nodes are connected. So it's a circular in a manner you can complete, like you can create circular linked list using singly linked list as well as doubly linked list. Now, various operations that we can perform in this linked list, in all of this, like whether it is a singly, doubly or a circular linked list, right? We can have like insertion, right? So in this we are having three variants, three types of insertion. Insertion at the beginning, insertion at the end, and insertion at a specific position. Similar way for a deletion also we'll be having three variants, right? Deletion from the end, deletion from the beginning, and deletion from specific position, right? So these all algorithms of like singly, doubly as well as a circular linked list that will be studied in the next video lecture. So I hope you understood all the like what is linked list, what is the structure of a node, what is singly linked list, what is doubly linked list, and what is circular linked list. So thank you very much.